Download this code from codegive.com, link in the description below. Git SSL certificate problem, self-signed certificates, a comprehensive tutorial. This tutorial addresses the common Git error related to self-signed SSL certificates. When you try to clone, push, or pull from a Git repository hosted on a server using a self-signed certificate, Git will refuse the connection because it doesn't trust the certificate authority, CA, that issued the certificate. This is a security measure to prevent man-in-the-middle attacks. However, it's often a problem in development environments or private networks where self-signed certificates are frequently used for convenience. This tutorial will explain the problem in detail, illustrate various solutions, and provide code examples to implement them. Understanding the problem *. Git uses SSL/TLS to secure communication with remote repositories. When you connect to a remote server, Git verifies the server's SSL certificate. A self-signed certificate is created by the server itself, not a trusted CA like Let's Encrypt or digicert. Since Git's default trust store doesn't include this self-signed certificate, it flags it as untrusted, leading to an error message like Solutions *. There are several ways to resolve this issue. The best approach depends on your specific situation and security requirements. 1. Accepting the certificate, least secure, use with caution. This is the simplest but least secure solution. You explicitly tell Git to ignore the certificate verification for the specific repository. This is acceptable for temporary development setups or trusted private networks, but never use it for production or untrusted servers. Using the -accept invalid certs flag, for a single command. This flag forces Git to ignore certificate verification for a single command. It's convenient for one-off actions. Or modifying the Git config, for persistent effect. This method modifies your Git configuration file to always ignore certificate verification for a specific URL. Warning *. This command disables certificate verification globally for all your Git repositories. This is highly discouraged due to the significant security risks involved. A better approach is to target only the specific URL. 2. Adding the certificate to the system's trust store, more secure. This approach involves adding the self-signed certificate to the system's trusted certificate store. This makes the certificate trusted by all applications, not just Git. The exact steps depend on your operating system. *Linux, using update CA certificates. 1. Download the self-signed certificate, your _certificate.crt or .pem. 2. Copy the certificate to the appropriate directory, example /usr/local/share/ca certificates. 3. Run sudo update CA certificates. *Mac OS, using keychain access. 1. Download the self-signed certificate, your _certificate.crt or .pem. 2. Double-click the certificate to open it in keychain access. 3. Select the certificate and click Trust. Choose Always Trust for the When Using this certificate option under Trust tab. Windows, using mmc.exe. 1. Download the self-signed certificate. 2. Open the certificate snap-in, start-run-mmc-file-add/remove snap-in-certificates-add-ok. 3. Navigate to Trusted Root Certification Authorities-certificates. 4. Right-click and select All Tasks-import. Follow the import wizard. 3. Using a custom CA file, most secure and recommended. This method is the most secure and recommended approach. You create a custom CA file containing your self-signed certificate and tell Git to use it for verification. 1. Download the self-signed certificate *, obtain the certificate from the server. It will typically be a .crt, .pem, or .cer file. 2. Create a custom CA file *, create a file, example cacerts.crt, containing the certificate. You might need to combine multiple certificates if your server uses an intermediate CA. 3. Configure Git to use the custom CA file *. Replace /path /to /cacerts.crt with the actual path to your CA file. This tells Git to only trust certificates found in this file when connecting to the repository. Example, using a custom CA file, with code. Let's assume your self-signed certificate is my_server.crt and you save it in /git_certs/. 1. Create the directory, mkdir/git_certs/. 2. Place the certificate in the directory, cp my_server.crt/git_certs/. 3. Set up Git. This configures Git to use only my_server.crt for verification, avoiding global changes and maximizing security. Choosing the right solution *. For temporary or trusted private networks *, the accept invalid certs flag or modifying the Git config, with extreme caution, might be acceptable for quick solutions, but avoid this in production. For long-term or shared environments *, adding the certificate to the system's trust store is a more robust approach, but requires system-level privileges. For maximum security and flexibility *, using a custom CA file is the best practice, especially in complex environments where you need fine-grained control over certificate trust. Remember to always prioritize security. Avoid disabling certificate verification unless absolutely necessary and in a controlled environment. If you have the option, obtain a certificate from a trusted CA to avoid these issues altogether.